and
ball
go around.
down. Drag and drop.
How do I have to drop it somewhere?
Bobby down.
I have to drag it onto the collider. So the steer collider.
What do you mean?
Do that. And then drag the physics material.
Singles
Dr. Goodrich,
Yes.
is it okay if there's like no frame whatsoever to our Newton's Cradle and just the spheres bouncing back and forth?
It would be nice to have a frame.
Okay.
Make
I
it
would like a
pretty
frame.
Because
Yeah.
the last time I tried it went crazy.
Okay, so
Don't attach it to anything. Just make it all
Yeah.
we'll talk about some of those issues. I'll show you my Newton's Cradle, and you can see what I did with it, so you can get yours to work, which is due today, Friday or 5 o'clock in the Moodle. And I'll make sure that I walk through what I need from you to turn them in. So here, let's get going. Not everybody's here, but class is starting. Maybe they're watching along line with Twitch, but hopefully they come to class. Yes.
Do you think that it would be okay to like bring back the forums?
Bring back the
Or just make a
forums.
side forum where we can like post comments and questions. Not necessarily towards you, but like towards each other.
Sure. I could try to open that up again on Moodle if other people thought that was helpful. Nobody commented on each other's stuff before, but you might want to now. Yeah, and because I do want you to learn from each other and say, oh, this is how I did my Newton's Cradle. Everybody pretty much is going to do it slightly differently. I want you to have that experience of seeing what happens. Okay, so a couple course details. Next Thursday is going to be your game canon presentation, your 3-minute presentation. So I need from you an email by the end of today with your top 3 choices for what you're going to present. You need to pick one game, and you're going to make a 3-minute argument with 9 slides behind you, moving at 20 seconds per slide about why everybody next time should play that game. Why is this game essential and different from the games that we all played? What is a new thing that it does? So I want you to send me your top 3 choices and rank them, because what I don't want is 17 presentations on League of Legends and 1 presentation on frog fractions. I need diversity among what you're going to be talking about. So send me your top 3 choices. I'll make sure everybody is arguing for a different game to be added to the game canon, and we'll get that process started. Thursday, I'll tell you more details about exactly how I want the presentation. I'll have that written up. I need for it to be in a Google document, and that's pretty much it. I'll tell you how to export it to get it ready for me so we can do the 20 seconds per slide idea. But think about that. Keep that in the back of your mind. It's coming up next Thursday. Okay. We are working our way through some pieces of Unity. Let's see where we are. Here is my Newton's Cradle. I have pieces in there. I made a ball rocker, which has a sphere, which has some cylinders attached to it. Each one of these is one of these balls. It's going to swing back and forth for us. I have a camera that's out here at an obtuse angle. I have a directional light from the top. And when I run it, this is the type of behavior you should be expecting to see. It's not perfect. Some of the balls still move in the middle once they're hit, swinging back and forth. But it's a pretty good approximation. What kind of difficulties were you facing as you were implementing yours? Yes.
I can't rotate a shape from the top of it. Like, it still wants to rotate about its center point.
Okay. So, let's see how we can work on that. The sphere is where I attached the cylinders to the ball rocker. I have this transform there. Here we go. Here's my hinge joint on my sphere. And the anchor that I picked for it is that orange arrow. And that orange arrow can be controlled of where is it relative to that sphere at the XYZ coordinates. So I can change that to be, say, 3 or 6 or 7. And it's changing that orange arrow of where the point is for that hinge. And the second part for the axis tells me what direction that hinge will let it swing. So there's flexibility in the Z direction for my axis. See, I can change this to be in the X direction, in the Y direction, both of them at once. Whatever vector you want to be where you swing, you pick there, and then your swinging is controlled by the location of that spot. So by putting it up at 7, it's probably going to do some other stranger things. You can see that middle one is rotating slightly differently because the hinge joint is now at a different place. Let's put that back where I had it. 5.5 seemed to work pretty well. You could use trigonometry to figure out exactly where it should be. Other questions? I sent out an email about physics materials. I made one called steel. And I went to Assets, Create a Physics Material. Because we talked last time that these are 3D objects. They react to gravity. They're physical objects. They have drag on them. But they're also some kind of physical property. And so this is how we would control what type of material this is. Is this rubber? Is this piece of cotton swab fluff? Is it steel? How is this going to react when it moves around the world? So the important part that I was changing was this bounciness. If we change the bounciness to 0, different things happen with our materials. Yes?
Can I see your ball rigid body property?
Yes. So from 0 to 1, definitely a different reaction of that material with the physics. So my sphere's rigid body, I went ahead and set the drag and angular drag to 0. I didn't want any kind of wind or other types of material stopping my momentum, but it does use gravity. It has a mass of 1. You can change things if you want, give things more mass. This one has a mass of 5. Whoa! And it breaks the whole thing. It is a much heavier ball coming in there together, and you pretty much break your cradle. So, if they're all of mass 5, they're all going to still react like they were before. Okay, what else did I have to do? My bars up here, which are still levitating, I need to attach them to something to make this really work like the physical world. I turned off their collider. When you put something into this world as a game object, one of those predefined cubes or cylinders or capsules and stuff, it comes with this kind of collider, which is good to say it reacts to physics. But I didn't want it to because I had, as you can barely see here, I had the cylinders that were my strings attached right to the middle of that. And if I did that and I turned this collider on, then when I run it, it's going to say there's a collision. I need to resolve it by throwing them away from each other. And now things are pretty much a little broken. They're sticking out to the side instead of being where they should, making it so it just exists in the world. You can see it, but it's not part of the physics system, and the collision system just makes it happen. Yes?
What did you use to connect your strings to the balls and the rails? Like your cylinders or whatever, they're acting as the string.
These strings?
Yeah.
Yes, I made them children of my sphere. So when the sphere moved according to its joint, those strings would also be moving. However the sphere moves, the cylinders are going to move relative as if they're part of that object.
How did you attach them, fix them to both points? You fixed them to the sphere and the top bar.
I fixed them to the sphere just by dragging them and making them children. So however the sphere moved, the cylinder would move.
I think he's asking how are they physically connected, and that's using hinges on the rigid bodies.
So
Yeah.
the sphere has a hinge joint, the way I made it. My cylinders do not have any connection. They are just children. But they move with the sphere because the sphere has the hinge joint. How did I make it so they look like they're also attached to this top bar? I did that with math. I did that just by calculating exactly where that joint should be is exactly at that level, or is close enough that you can't really tell, to my top of where those strings attach to my bars. And so it looks like they are attached, even though they're not. And this happens a lot when you're making a game or a 3D simulation like this. You make it look like it's awesomely connected, but underneath you do as little as possible so you're not burning cycles. Even if the physics under it don't do the actual real world, this stuff gets close to the real world. But if you're running out of cycles and you're just saying, I want this awesome thing to look great, fake it. Make it look nice. And there's things we'll learn as we go about baking things. There's lights. There's ways to make lights as you move around. There's a little spotlight or something like that. If the light is not going to move, you don't need to spend cycles of your program updating the light on the wall. So you can do something called baking it in. You can bake in your lights, you can bake in your navigation, you can bake a lot of stuff, which eventually says it's like a cake, it's all gooey, but when you bake it, it sits it and it's stuck. As you're doing these animations, real-time calculations, you want to bake as much as possible and fake it so that it's just there and people don't notice it, but it still looks like it's running perfectly. I think, does that get to your question, Mark? Mm-hmm. So I did as little as possible. I didn't attach a joint here and a joint there and here a joint everywhere to make it all fit. I just made one joint into the magical space in the middle, and everything else looks like it's perfectly connected. Other questions? Do you have one, Barrett?
I just want to clarify that if you remove those top bars, that it would do the same thing. I guess you answered my question.
Yes, those top bars are just for visual presentation. There is no connection between the objects. I could remove these sidebars completely, and I would still have my spheres swinging in the right places. Everything else was just for show.
Your cylinders your strings don't have a rigid body, do they?
My,
Your spheres.
my strings do not have a rigid body. They do have a collider. I really don't need that collider. So I could probably take it off and then it won't do that calculation every fraction of a second. Say, hey, did this collide with anything? So might as well turn those off while you can. Okay, any other questions? hopefully you made a lot of progress, had some